In this video, we're going to introduce you to forces. And if you're at home and you've got some of this stuff we're going to talk about, why not play around with these things when you're at home? So let's have a look. The items provided underneath, what we do in class, and we would provide all of these different items. And you have to identify as many different force types that the objects can be used to show. So I'm going to quickly go through some of these. Okay, so we've got this one down here. What does that do? Well, that floats on top of water. That's buoyancy. So that's the kind of force that we might talk about in this video. You have got here magnets. So you've got down magnets at the bottom. So this is a magnetic force. You've got friction from sandpaper if you rub it on something. Okay, you can get static electricity from this one. Okay, you can get compressibility in this one because you can squash it, and compressibility here because you can squash the spring, and you've got elastic forces as well because it can spring back in your face as well. But anyway, we're going to split the forces from these different objects, okay, into two types, contact and non-contact forces. And we've got our wonderful Yoda here with the force, okay, young Padawans. So let's look at these different forces, shall we? So we talked about a few of them at the start. So we've got that buoyancy from the duck. Okay, support is just a table. So if you put something on a table and it's held up, something like that, it's called support. Electrostatic is within elements, atoms, and things like that. So if you know a little bit about atoms, you know that atoms are made of protons and electrons, and the attraction between those two is electrostatic. Okay, now we've got magnetic. Okay, we've got tension. Okay, and we've got drag and air resistance. Gravitational, that's when basically you're holding something up against gravity. So if I hold an apple here up against gravity. Okay, friction. Okay, stopping me from moving because my foot is on the ground. And that's really, really important. So if you've got friction when you slip, which is a lack of friction. Okay, and you've got friction when you grip, which is more friction. Okay, but we'll go through all of these again once we split them up. So before I go into the next one, try and split them into non-contact and contact forces. So here we go. So friction. Friction has to be in contact with something. It's my foot being in contact with the ground. Okay, it's friction, or the sandpaper being in contact with the wood. Okay, tension. Tension, it's when something in tension, something's being pulled apart. Okay, so under tension, or someone has a weight in it and it's bending because of the weight that's going on at tension. Support, like the table, has to be in contact with the table. Buoyancy has to be in contact with the water for that buoyancy to happen. And upthrust. Upthrust is like a rocket going upwards. Okay, and drag and air resistance is when you are moving really quickly, the air hitting you as you're doing it, or a car or something like that. And the ones that are totally invisible, and let me just go back to that. Actually, the drag and air resistance is contact because it's the air hitting you that's stopping you from going as quickly. The invisible ones, electrostatic, magnetic, and gravitational. Okay, you can't see gravity. There's nothing there. Magnetic, there's nothing in between them, but they still want to come together. And electrostatic is within the atoms. Now, force is an interaction between two objects. So let's have a look at these two objects here, this lovely man right here. Okay, and let's look. Well, there's an interaction. A force is pushing the ball on. Okay, and let's have a look at the other one. The force is happening there, and you're pulling the box. So forces can be split into two types, a push and a pull. That's two ways of categorizing them. Now, push and pulls occur when the two objects interact, and you can't see the forces essentially, but the effects of them can be seen. Now, force can be a contact or non-contact, as we've discussed. For the contact forces, the objects must be touching. Okay, so they must be touching, and so friction, the two surfaces rubbing together, air resistance, a frictional force with the air slowing you down by hitting you, tension, a force that acts through a cable, wire, or a string. Non-contact forces. Gravitational acts between two objects with mass. So, for example, the Earth and the Sun. The Earth is going around the Sun and being held in place by gravitational attraction. And we are sitting on top of the Earth and we're held in place here by gravity. We can't jump off the Earth. Electrostatic, objects with charge like protons and electrons, and magnetism between two poles or two magnets. Okay, so this is not touching and this is touching. Okay, so forces can be measured in newtons. Okay, and they can be measured using a force meter, or also called a Newton meter. And you usually hang it on this hook, and then it'll tell you what the force is there. Okay, forces always come in pairs. Okay, so let's have a look at this force. The spring loaded and there's let go, and you're finding that it puts a force on the blue car and it puts a force on the purple car. So that means it's acting in a pair. So a force is going that way and a force is going that way. Okay, so if that is the case, the blue car pushes on the purple car and the purple car pushes back on the blue car. So you've got two pairs of forces. It's equal in size and acts in opposite directions. You see they both went in opposite directions and of equal size. Now, forces always come in pairs. Let's look at another example. So here, an apple is falling towards the earth, okay? Now there is a force that's holding that apple up, and there's a force that's pulling it down, okay? So the earth pulls on the apple, and the apple pulls back on the earth, okay? It's acting in that kind of pairs. The force on the apple and the earth is equal size, but acts in opposite directions, and we know that because it's not moving, okay? Right, now vector quantities. Now forces are vector quantities, which just basically means there are two parts to it. It has a magnitude, a size, and a direction. So I'm walking this way, so the direction is this way, and the force must be pushing me this way, okay, must be higher than the force pushing me that way. Okay, but we'll talk about examples like that in a minute. Okay, magnitude and direction. And it has different effects, and you've got to tell those effects when you come across questions. Okay, and we can represent those using arrows. So let's have a look at the arrow. Small force acting to the right and a large force acting to the left. So they're in pairs and they're acting in opposite directions. All right, let's have a look at this in some proper examples. Okay, let's look at this. So we've hit a ball and it's going to the right. So that object is starting to move or it's speeding up. So basically, if there's a bigger force going this way than going this way, then the object is going to start moving or speed up. Okay, so remember they act in pairs. So there's got to be a force coming in the other direction. Okay, so the force when it comes to the ball that's slowing it down is air resistance, and it can be the contact force with the ground as well. And that will stop it moving and slow it down. Okay, now let's have a look at the next one. So it's going in a different direction now. So the different direction, they can cause an object to change direction if the force is applied at a certain point in a certain direction. You can also do a turning force. That's called moments. And that can cause an object to turn and rotate. Now, let's have a look at some options now. So the size of the arrows usually are to scale which the size of the force. So we've got two opposite forces pulling outwards. We've got two opposite forces pushing inwards. And we've got a force on this end that is twisting, and we've got a force on pushing up and a force putting down. So what do we think is going to happen to the shape of these objects if that's the case? Let's have a look. And you can see that one is being stretched because the forces are going out, one is being compressed because the forces were going in, one's twisted on that end, okay, and one is bent because it had two forces going up and one force is going down. So you can cause an object to change shape if you apply the forces in a certain way. Now, depending on how the force acts, it can have different effects. And these are the effects that we've summarised in the last few slides. It can move, start moving, speed up, it can stop moving, slow down, it can change direction, it can turn or rotate, and it can change shape.